Welcome back. This is our last section of 5.2 right triangle trigonometry. And in this section, we're basically doing applications of right triangle trigonometry. They're similar to word problems where you are using sine, cosine, or tangent, or any of the inverses, any of the reciprocals to help you find a missing side or a missing angle, but now they are real world problems. The first example says, sighting the top of the building, a surveyor measured the angle of elevation to be 22 degrees. The transit is 300 feet from the building. Find the building's height. What you're going to notice, a lot of these problems, you want to draw, and basically we're doing a right triangle. And this side will be your building. And here's your transit. And then you label the triangle. They said the angle of elevation, so to elevate means you're looking up. So that would be this angle, which is 22 degrees. And the transit is 300 feet from the building. So this is 300 feet. And they want us to find the building's height. So you look and see from our trig functions, should we use sine, cosine, or tangent to find the building's height? So if you notice, according to the angle 22 degrees, this is adjacent, but we need the opposite side. So that means we are doing tangent. So just like in the previous section, we're going to do tangent 22 degrees equals opposite over adjacent. And then you're going to solve for x, making sure that your calculator is in degree mode. And so once you solve for x, you would multiply both sides by 300. And multiply this side by 300. Putting that in your calculator, you're going to get 121 feet. And there you have it. So you just have to make sure you're picking the correct trig function to find what you're looking for. In this example, it says a building that is 21 meters tall casts a shadow 25 meters long. Find the angle of elevation of the sun to the nearest degree. So I'm going to draw my right triangle again. And I'll just change, it doesn't matter which way you face it. But here's my building. Angle of elevation, remember, meaning you're looking up. We don't have the angle this time, so we're going to call it theta. But they did tell us that the building was 21 meters tall. Shadow, here's the shadow on the ground, is 25 meters long. So, thinking back to our ratio, we don't have the hypotenuse. So the only trig function that doesn't require the ratio of the hypotenuse is tangent. So we would do tangent theta equals opposite over adjacent. Now, if you remember from the previous section, when you have to find the angle, you're going to use the inverse key. So typing in your calculator, you do tangent inverse opposite, which was 21, divided by adjacent, which is 25. Make sure you do inverse and not reciprocal key. So this is, in most calculators, you have to hit second or shift to get to the inverse key. And then doing that, you should get 40 degrees as your answer. So if you have to find the angle, you have to use the inverse symbol or the inverse key. This example, a telephone pole is 55 feet tall. A guy wire, 80 feet long, is attached from the ground to the top of the pole. Find the angle between the wire and the pole to the nearest degree. So drawing my right triangle again. The telephone pole, here's a pole, 55 feet tall. The guy wire, that's the wire here, is 80 feet long because it says it's attached from the ground to the top of the pole. So that's 80 feet. Find the angle between the wire and the pole. Well, if you don't know which angle, this angle is the wire and the ground. This angle is the wire and the pole. So according to this angle, let me write SOHCAHTOA. We have the adjacent side and the hypotenuse now. So the only trig function that has that ratio is cosine. So you have to do cosine of theta is equal to adjacent over hypotenuse. So since we're missing the angle, remember you have to use the inverse key. 55 divided by 80. So that angle would be 47 degrees. And then you are done.